Good afternoon, ladies and gentlemen, and welcome to ACC Science Tips. We already talked about this a little bit before when we did the charts and graphs, and just to sort of review a bit, there's actually 3 different sections to the ACT test. One's going to be about charts and graphs. If you remember that each one of those usually has about 5 questions. They might mix in 6 questions now. After you get done with the charts and graphs, it'll be the section that we talk about today, and that's all about experiments. You're going to have different experiments that you have to analyze, and they usually have 6 questions in them. And then the last section that you're going to try to wait till the very, very, very end to do is you're going to be your fighting scientist that usually has 7 questions. And there's only one fighting scientist section, and that's why you do that one absolutely last. So there's a total of 40 questions. You get 35 minutes, and basically what you do is if a section has 5 questions in it, you only give yourself 4 minutes to do it. If it has 6 questions in it, you give yourself 5 minutes to do it. So you're always giving yourself 1 less minute than you have questions. Now, what we're going to talk about today is the experimental analysis question. So I want everybody to take time, if you need to stop the video and write these down, probably a good thing to do. So question number 1 is just like the questions in the charts and graphs, where you simply have to read data from a chart. So it's usually pretty easy. Question number 2, once again, just like the charts and graphs section, you have to extend the data when you're reading a graph. So the graph might only go up to, let's say, 100 on the x-axis, but it will ask you, what would your data point be at the 110 mark? So you got to extend the line out a little bit. Another type of question, and number 3, is you're going to have to predict data between 2 points on a chart or a graph. And so let's just say if they gave you a chart that went 10, 20, and then went to 40, 50, you'd sort of have to predict what that 30 point would be. Number 4, you had to find the relationship between if one variable goes up, what happens to the other variable. Once again, sort of like the charts and graphs section. So these 2 things are quite a bit alike. But in the 5th and 6th question, that's where it becomes different in the experimental design, because at the end of an experiment, you have to make a conclusion based on data. So the 5th and 6th questions are always going to be the toughest ones. The 6th question is always the hardest because it's what we call an if-then question. So they're going to say, if this happens, then what would be the outcome? Okay, so if I change this data, then what would the conclusion be then? So once again, if you didn't have time to write all that down, go ahead and stop the video, and we're going to get ready to do a practice set. So make sure that you have in front of you some data or the questions that look like these. So it's going to be passage 4, where you have all this stuff about radioactive waste and the different rock it's buried in. And then you're going to have 6 questions that look, I don't know where I put them now. I'm going backwards, my fault. 6 questions that look like these, where the first one is according to study 2, okay, and so forth. Okay, so just like we did last time, we're not going to read anything. We're going to try to save some time, and I'm just going to go to the first question because I always know it's going to be a reading a chart question. So it says, according to study 2, the thermal conductivity of rock salt measured at 500 degrees. Well, if you look at study 2 here, let me see if I make this big. Oops, I'm going to make this one small now. It says at 500 degrees, well, there is no 500 degrees. 500 degrees would be extended beyond the chart over here. This would be 500. So all of these are sort of going down to the same number, which is roughly right at the level of 2. And so therefore your answer is going to be 2. So once again, that's an extend the data problem. Let's look at question number 2 here. In question number 2, it says, according to study number 3, which I have over here, if another set of temperatures have been calculated for 1,000,000 years. So let's look at this one over here. And let's go out 1,000,000 years. Well, shoot, the daggone chart only goes up to 100,000. So once again, we're going to extend it out to 1,000,000. And all these things are sort of coming down this way. And so I think it ended up being almost 0 degrees, 0 degrees Celsius would be the prediction for this one. So once again, it's always extending the data, trying to read a chart, something like that. Those are usually the first couple are very, very easy. Number 3 is where you have to figure out the, I'm messing up here. Number 3 is where you have to figure out the data in between two charts. So let's look at question number 3. Sort of weird. It says welded tough. I've never heard of welded tough. Another type of rock has a thermal conductive of 1.8. If the temperature of this rock type adjacent to the SF canisters were taken in study 1, the recorded temperature would be. I have no clue what SF canisters and all that stuff is, and so I'm just going to look at these numbers. So 1.8, if I look at study 1 on 1.8, so let's look at 1.8 study 1. I got to go find out where study 1 is and move all this stuff out of the way here. Well, by golly, there is no 1.8. Well, that stinks. But wouldn't 1.8 be between 1.57 here and 2.8? So what I have to do is I got to pick a number between 121 and 146. Well, I know it's going to be in the 130s, and so that's why D ends up being my answer. Okay. Number 4 is a relationship question. In other words, if one thing goes up, what happens to the other? So according to study 1, which of the following best describes the relationship between conductivity and temperature? Well, here you basically see temperatures conductivity is going down. And as these go down, if you notice, these are going up. So the exact opposite happens. So the answer in this one of these, if one thing goes up, it would decrease only. Now we get into the tough questions. In the tougher questions, if you haven't read it, it's going to be harder to answer them. Well, let's just see if we can make a logical guess. It says, based on the information provided, this is number 5, which of the following rock types would be the safest? Okay, and it gives you this list. Well, I want you to look at this chart right here. The whole thing here is a relationship between thermal conductivity and temperature. Well, if you notice, thermal conductivity, this dotted line right here, dash line right here, it has a lot of conductivity and it goes down to the same temperature as all the rest of them. So since it's making the biggest change, that's the one I'm going to pick. And so my answer would be this dash line, which in this chart up here is rock salt. Okay? And then finally, number 6, the absolutely toughest question. Oops, sorry about that. Erase all this. Number 6 asks you to actually have an if-then statement. It says, which of the following procedures in studies 1, 2, and 3, so this is why it takes so long, because you got to look at all the studies, would best test whether the amount of heat generated by SF is related to the mass? Well, let's just start reading these things. I'm not even going to read the questions because I don't have time. This video is already 8 minutes long, and you only get 5 minutes to do this section. So let's look at this. It says, following the design in study 1, but using concrete canisters containing 0.4 metric tons. Well, the original study had 0.4 metric tons, so this has the same mass as the original study, so that wouldn't test mass at all. So I know that 1 is not good. 2 says, following the study 1, but now you're going to use 0.8 metric tons. Well, if you look at study 1, it says that all of them used, all of them used 0.4 metric tons, which you can see right here. I'm ready to circle it. Let me erase this. Sorry. But if you look, it says right here, 0.4 metric tons. Well, this one's using 0.8 metric tons, so that would be changing the mass. So 2 for me is a possibility. Number 3, using the design of study 2, determining the thermal conductivity with twice as much of each rock. Well, that sounds like a great idea because I would be having twice as much mass. But the thing is, study 2, which is stuck behind here, sorry about all this. Study 2 didn't have, it doesn't have any procedure to it. So therefore, I can't use a procedure that they never gave me. So study 2 is not a good one. Right? So 3 is not necessarily a great answer, even though it's a possibility. And then finally, study 4, or number 4 says, following the design of study 3, but determining the rock temperatures 0.5 kilometers. Well, kilometers is not mass, so therefore it has nothing to do with the actual question. So my best answer is 2. Like I said, number 6 took me a long time, and I'm not that fast of a reader. So usually I sort of skip the last one if I have to and go on to the next section of the ACT, because I know that questions 1, 2, 3, and 4 are usually going to be easy. So I make sure I get the ones I know how to do, and then I can come back and take better guesses on the other ones. Now, if you're a fast reader, don't do it my way. If you're a fast reader and understand this, you go ahead and make your best guess and go on. Everybody has to do something different. All right, hope this helped on the experimental design questions. Once again, let's go back to the type of questions there are. There's 6 different types. The first one is always going to be that you, whoops, hold on here. The first one is always going to be that you hello. Sorry. Gotta go down, Jeffrey. Go down. Come on, bud. There you go. So the first question is going to always be reading the data. Then you're going to have to extend the data on a graph, or maybe predict the middle of 2 points, something like that. So that's going to be questions 1, 2, and 3, or simply reading data. Question 4, you're going to be looking at if one thing goes up, what happens to the other? Does it go up or down? It's called a relationship question. And then the 2 hard ones are you got to make a conclusion based on data. And then the hardest one's going to be an if-then question. Now, here's one little trick before I leave. If they ask you to identify the control, the answer is usually A, since it's the first thing being tested. Okay, so once again, if they ever ask for the control, go ahead and write down A. It usually is the right answer because it's the first thing that's tested. All right, hope this helps. Have a great day. Bye.